Hello, Winaway class. Mr. McHugh back here with you, and we are on 9.5 still. Going to tackle page 5. And oops, hold on. We got something going on here. Okay. Section 9.5. Okay, now we're ready to go. And we're going to tackle, I mentioned in the last video, horizontal and vertical shifts. And in summary, all you're going to do is merge everything you learned about the vertical shift and the horizontal shift, and the form of the quadratic equation is now going to have your x minus h. H is, I love that variable because that's the horizontal shift. Remember what? Opposite direction. That's a quick summary way. And whatever the k or the constant is, that's your vertical. Okay, so they're going to give you a couple equations. The key thing to start these is find the vertex. It's the parent parabola, again, which is y equals x squared, moved around, up, down, left, or right. That's all we're working on. And so all you're going to do is first find a vertex, and then once you find that, I'm going to show you in the bottom of this page. You pick an x point below and above it, and you've got 3 points, and you're good to go. Also, side note, I am going to make whiteboard video number 20, and I am going to talk about graphing this horizontal and vertical shift on the whiteboard, and also talk about how in MyMathLab, how are you supposed to use, it's called the the parabola tool, and it looks like this, by the way, and it's got a dot down here. In fact, I'll talk through it right here, and 2 dots. When you do these problems, you got to graph the symmetry of the parabola was taken advantage of by MyMathLab programmers, and all you're going to do is on an XY axis here. In fact, let's just pretend practice here. Look at this example 3. It says f of x, which could be y, equals quantity x plus 3 squared minus 2. Now, the task is to find a vertex. Okay, so remember, h comma k is your vertex. It's always an XY ordered pair. Think of horizontal and vertical. Sometimes I wish they almost would have used the letter V there. But so opposite of plus 3 is minus 3. The vertical, which is the k on the outside, you keep. Okay, so negative 3 comma negative 2. Let's go back up here to MyMathLab. What you're going to do here to find that vertex and to use this tool is here's negative 3, here's negative 2, and so from the origin, what you're going to do is you're going to click on this palette toolbar. You're going to click on it, and then you're going to come over to negative 3 comma negative 2, and you're going to snap or left click on the mouse and put that vertex point. As soon as you do that, a parabola, as you move your mouse, is going to get moved around, and then we've got to decide exactly where to put it. Okay, now I'm going to come down here a little bit and cheat. Pick a point down here. Vertex was at negative 3 comma negative 2. I'm going to go negative 1, and when you put negative 1 in and square it, you get negative 1 plus 3 is 2 squared, which is 4 minus 2 is 2, and so the next vertex is 1 comma 2. Okay, then all you got to do is come up and find negative 1 comma 2, which would be, here's negative 1 comma 2, and then you snap again. Okay, so I think I'm going to try to show this on MyMathLab too. So you snap the vertex as the parabola is created in a little dashed line. You snap a second time, you click on any point that goes on the parabola, and it graphs it this way, and automatically the symmetry happens. And then that corresponding pair over here would be on there too. Okay, so that's how you do that. Now let's get back to this problem here. So now that you got the vertex, I want to show you something here. I kind of expanded this problem and challenged you. What would you do if the problem looked very similar, but it was x minus 3 squared plus 2? What would that vertex be? Okay, I'll let you think about it for a second. What do you do with inside the horizontal shift is what? Opposite, so it's a plus 3. The vertical never changes, plus 2. Down here, look at example 3b. So it's a plus 3 inside the horizontal shift, and I remember horizontal because of the parentheses are going horizontal. Okay, opposite of plus 3 is minus 3, and bring down to plus 2. One more option might be, what if it was x minus 3 quantity squared minus 2? Vertex would be opposite of plus 3. Nope, excuse me, opposite of negative 3, which would be a plus 3, and bring down the negative 2. Remember, it's always x comma y, horizontal shift, vertical shift. Okay, so I'm going to show in the next video, next page, the graphing on some of these to get comfortable with that. But basically, the parent graph is being shifted those many units horizontally and vertically, and then you're going to graph it. Now, how do you do that in MyMathLab? What you want to do here is use an expanded XY table real quick. You already found the vertex and -3. I'm going back up to this problem up here, by the way. Sorry, working on the original example 3. So vertex is -3 for x. Put that in. -3 plus 3 is 0 squared, and that's what you want, that 0 value inside the parentheses. 0 minus 2 produces an output of -2, and there's your -3 comma -2. Now, once you know that, all you got to do is go 1 or 2 units below it. I like to use 2 units just to get a little bit of distance, but don't go crazy. Don't go 5 back and 5 above. You'll be off the grid. Go about 2 back. So go back to -5, go up to -1, input, process, get your output, and there's the symmetry between -5 comma 2 and 1 comma 2, and there's your vertex there. Okay, Mr. McHugh here. I'm going to go ahead and make that whiteboard video number 20, and when I see you on page 6 or class notes, I'm going to go ahead and take advantage of that graph and put a couple more graphs on there. Okay, so till then, take care. We have wrapped up page 5, so good job everybody, and good luck on your graphing there. Okay, take care, and I'll see you later. Bye.